I'm Anil Kumar, and now here is an extension to our question, which was actually developed by Tasfeia, my student. Question is, Natasha is planning on going to the annual county fair in Montana. She plans on going on the famous Ferris wheel called the Swinger. The Swinger completes one rotation in 50 seconds with maximum height of 56 meters and boarding height of 14 meters above the ground. Determine an equation to model the height of a person. Find the possible duration when the average rate of change in the height is 1 meters per second of the person riding this wheel. And now it is the part C which we are going to look into. Find time when the instantaneous rate of change is 1 meters per second. In part 1 and 2 we answered questions A and B. Now it's time to answer part C. We need to find instantaneous rate of change, right? Should be 1. So the time when the instantaneous rate of change should be 1. That is what we need to find. So for that, actually, we need our equation also. So let's just do a quick reminder of what we had done. This was 56 maximum, right? Minimum is 14 for us. Perfect. So with that, we get the axis, which is right in the center, which is 56 plus 14 divided by 2, 70 and 35. So that is 30, and that's somewhere here, right? 35. So that becomes the axis for us. To find the amplitude, we'll take the difference and then divide by 2, right? So this is axis. For the amplitude A, we say let's add them up, difference, right? 56 minus 14 divided by 2, and that is 42, so it is 21. And we know the time period T is 50 for us, and that gave us the K value 2 pi by 50, or we can say pi by 25, correct? So that gave us the equation which we wrote in part A, and the equation we started with minus cosine, right? Since we do not want to include phase shift, it's already a complicated question. So amplitude 21, correct? Cos of K value pi by 25, right? So pi by 25 T, and no phase shift, and X is moved to 35 units. Let's write 35 here, plus 35. So that gave us the equation here. Second part was to find duration when the average rate of change of height is 1 meters per second for a person riding, and we found a very interesting solution. That is, if I draw a line which is y equals with slope of 1, so that means y equals to x, and since I wanted to take initial point at 14, right, so I said plus 14, and the 2 points which gives us the intersection, rather there are 3 points, these set of points will give us average rate of change of 1, right, since slope of the line is going to be just 1, right? Now the question is, find time when the instantaneous rate of change is 1 meters per second. Now we're talking about instantaneous rate of change. How are you going to find? Well, for some of you, you can apply this formula, instantaneous rate of change, let me write, which is f of t plus h minus f of t, right, divided by h, where h approaches 0. You can expand, simplify, do all that, and then equate this to 1. Find t. This is one solution which some of you can do. Some who have already done calculus, I know many of you will be taking it next semester, so for those it may be simpler. They can find the derivative, and derivative of cos is sine with negative sign, so it becomes positive here, so it becomes 21 sine of everything, which is pi by 25 t, and all this times pi by 25, right? So I'm not getting into this detail, but anyway, so this is what the derivative is, right? So let me be very clear. This is multiplied by 21, not by anything else, correct? Like this kind of, okay? So now you understand. And of course we can equate this to 1 and find t. Well, that is not difficult. Once you know the derivatives, it could be done. But those of you who have not done derivatives, for them applying this method is not possible, correct? Anyway, using this method, let's find a quick solution. It's not difficult at all. We can now say that sine of pi t by 25 is equals to, taking these terms, cross multiply, that is 25 divided by 21 pi, right? So we should use calculator. Setting should be in radians. Whenever you're doing all these things, especially calculus, setting has to be in radians, right? So we have 25 divided by 21 equals to, divide this by pi, and then equals to, we get equals to 0.37894. Okay, now we'll do sine inverse of this. So we get pi t over 25 equals to sine inverse of this angle, which is 0.37894. So we do shift sine inverse, answer bracket close, equals to, we get 0.38865. Okay, so that is what we get, and from here we can find time t. So t equals to whatever this number is, 0.38865. We'll multiply by 25 and divide by pi, right? So we get our time. So let's do that. So times 25 equals to, divide by pi, right, equals to 3.09. 3.09 is the answer for time, and that time is in seconds. So at 3.09 we do get instantaneous rate of change, which will be 1, and that is exactly the point, right? So on this scale it will be kind of very close here. Do you see that? Now that is the way to do it algebraically, right? So we got our answer. That's very good. How can you do if you don't know all this, right? That is my question, which my students don't know, right? They're doing just functions now. Next semester they will do calculus. Okay, so how are they going to do it? Here is your method, right? Your method is very simple. Last time we did graphically. We have drawn a straight line here with a slope of 1. This time we are going to do the same thing, but we'll move the line up and down so that it forms a tangent. That is what instantaneous rate of change is. Instantaneous rate of change means we're looking for a tangent to the curve. Do you see that? Tangent to the curve. So now we move our line, and if I move my line slightly downwards, I'll get a line parallel to this, and I'll get my answer. You get the answer, right? That is how I'm going to get my answer graphically. I could also move it upwards and around this point, which from the symmetry, around this point, slightly less than 25, to be precise 3 units less than 25. So at around 22, right, from these calculations, and you can see this is 25, so slightly less than 25, we'll get a tangent to the curve with slope of 1. So that will give us, so we have our solution, and the answer is approximately 3 seconds, or it could be 22 seconds, as you can see from the graph. And how did we do it? Draw, let me write it big and bold, tangent with slope of 1, right, on the curve. That is what you do, and then find the point on the curve where it fits in. Perfect. So that is how you're going to do at this level. Perfect. I hope you highly appreciate it. You can write down your comments, share it with your friends, and then look for some more questions which we'll post soon on the same topic, since Tasfeia has worked hard to give you 6 questions on this particular topic, which will cover all parts of trigonometry you have learned in functions so far. Thank you and all the best.